Hello viewers, welcome back to another section of my multivariable calculus tutorials. So in our previous tutorial, we'll be solving surface area of quadric surfaces over regions. We still continue in this video. In this video, I'll have a problem and it says find the area of the portion of the surface z which is equal to f of xy, which is equal to the square root of 25 minus x squared minus y squared. That lies above the closed disk x squared plus y squared less than or equal to 9, right? Okay, so kindly watch this video to the end and don't forget to like, subscribe and share. So what is surface area? Surface area is simply double integral of square root of fx squared plus fy squared plus 1 dA, right? So the first thing is to find out fx, you find out fy. What is my fx? From what I have here, from my expression, so my f of xy is equal to square root of 25 minus x squared minus y squared. I'm going to find the partial derivative with respect to x, so watch closely. Fx, when I'm finding the partial derivative with respect to x, y will be 0, sorry, y will be a constant, 25 will be a constant. So this is a composite function. To find the derivative with respect to x, I'll first treat what I have inside as a 1, then I'll treat everything as a whole. So finding the derivative of my inner function, since this and this are constant, I'll get negative 2x, right? Then the whole thing multiplying, considering the whole thing as a whole, I'll get 1 out of 2, 25 minus x squared minus y squared all to the power negative half. Then this simplifies to this half will cancel 2, so that I'll get negative x over the square root of 25 minus x squared minus y squared. And this is my partial derivative with respect to x. Now what is my partial derivative with respect to y? My fy similarly will give me what? Negative 2y half 25 minus x squared minus y squared all to the power negative half. Then this will cancel out, so I'm going to get negative y over the square root of 25 minus x squared minus what? Y squared. The next thing to do is to find this expression, square root of fx squared and fy squared. So I'll get a square root, a big one, negative x over the square root of 25 minus x squared minus y squared all squared plus negative y over the square root of 25 minus x squared minus y squared all squared plus 1. So with this, I'll get this place to be equal to x squared over 25 minus x squared minus y squared plus y squared over 25 minus x squared minus y squared plus 1. Since they have the same base, I'll just add the top, so that I'll get the square root of x squared plus y squared over 25 minus x squared minus y squared. All this plus 1. So I'll multiply this by this using the algebraic form. So you get x squared plus y squared plus 25 minus x squared minus y squared, everything over 25 minus x squared minus what? Y squared. Then this will cancel out, so I'll be left with 25 over 25 minus x squared minus y squared, giving me 5 over the expression square root of 25 minus x squared minus y squared. So this is what I'm going to integrate over. I was given a disk which is x squared plus y squared is less than or equal to 9. So meaning my radius squared will be equal to what? 9. My r will be what? 3. So r is going to be less than or equal to 0. Then so greater than or equal to 0 and less than or equal to 3. Then a disk, our theta, is simply going to be greater than or equal to 0 less than or equal to 2 pi. So what I'm left with is my double integral 0 to 2 pi inner 0 to 3 of the expression 5 over the square root of 25 minus x squared minus what? Y squared. R d theta. Nicely. So once I get this, the next thing to do is my simple computations, right? Yep. So this, I still go by my substitution. So I'm going to integrate this with respect to r. But don't forget, this is x, this is what? Y. We need to send it to the polar coordinates before we can do that. 0 to 2 pi, 0 to 3, 5 over the square root of 25 minus r squared, r d theta. Nicely. So at this point, let u is equal to 25 minus r squared. The u over the r is simply negative 2r. Therefore, my dr is simply 1 over negative 2r du. Then I make my solid substitution. Integral 0 to 2 pi. Then I'll have integral 0 to 3, 5 over root of u, then multiplying 1 over negative 2r r dr d theta, right? Yes. So at this point, my r will cancel this r, and I'm going to be left with this expression here. I have, so I'm going to be left with the integral 0 to 2 pi integral 0 to 3 5 over u half, then the u d theta. Okay, so at this point we have integral 0 to 2 pi here. Then I'm going to integrate this, so I'll add 1, I'm going to get half, then I'll come to multiply. So realize I'm going to get integral 0 to 3, sorry, let me cancel this. So integral 0 to 2 pi, then I'm going to have my 2 multiplying negative 5 on 2, then u to the power half from 0 to 3 d theta, right? Yeah, so integral 0 to 2 pi, then here I'm going to get negative 5, my u is 25 minus r squared, all half 0 to 3 d theta. So 0 to 2 pi, I'm going to put 3 inside, so negative 5 out. I'm going to have 25 minus what? 9 to the power half minus 25 minus 0 to the power half d theta. 0 to 2 pi, this becomes 16, so 4, 16, then I take the square root, so negative 5, I'll have 4 minus, this will be what? 5, right, d theta. So this will give me integral 0 to 2 pi, then I'll get negative 1, so 5 d theta. At this point, I integrate with the theta, so 5 theta 0 to 2 pi, and I'm going to get 10 pi. Thank you for watching this video. Don't forget to like, subscribe, and share.